Hi everyone. Now I am going to discuss about the four problems today. I have selected the four problems from Pathfinder, Krotov, and irodov. All four problems are like a similar kind of problems. I have pasted these all four questions we can see here. First question, this is a 11th question from the work energy power chapter from the Pathfinder methods of the work and energy. A question is given like this: a small disc placed on a frictionless horizontal floor is attached at one end of a light inextensible cord, the other end of which is attached on a vertical cylinder fixed on the floor. The disc is projected with a certain velocity perpendicular to the cord and along the floor. How will the tensile force in the cord and speed of the disc change during the enduring the motion? Options are given like this: both will increase, both will remain constant. Tension and speed they're asking actually. Tensile force will increase and speed will decrease. Next we can see that tensile force will increase and speed will remains constant. We can try this one before seeing my solution. Okay. Similarly, a 21st question from the Pathfinder also I have taken. This is also same question actually, but they are asking in a different way. A disc placed on a large horizontal floor is connected from a vertical cylinder of radius r fixed on the floor with the help of a light inextensible cord of length L as shown in the figure. Figure you can see here, like 11th question now, the both the figures are same here. Coefficient of friction between the disc and the floor is mu. The disc is given a velocity u parallel to the floor and perpendicular to the cord. How long will the disc slide on the floor before it hits the cylinder? Now you can see the coefficient of friction between the disc and the floor is given. This is also a Pathfinder question from the same chapter, methods of work and energy. Okay, this is a question number 21. Okay, you can also try this question before showing my solution also. Okay. Third question, what I have taken in the same similar kind of model. This is I have taken from the Krotov. This is from the 71 first chapter mechanics 71 question. A ball is tied by a weightless inextensible thread to a fixed cylinder of radius r. At the initial moment, the thread is wound so that the ball touches the cylinder. Then the ball acquires the velocity v. You can see here, ball acquires the velocity v in the radial direction and thread starts unwinding. Determine the length L of the unwound segment of the thread by the instant of time t, neglecting the force of the gravity. So diagram is given like this. This is from Krotov 1.71. Okay. Fourth question, this question also Krotov question. You can first try by yourself before showing my solution. Already I have written the solution. I will show that one. Okay. Fourth one, you can see a horizontal. This question I have taken from the irodov, same from mechanics, first chapter 138 question. A horizontal plane supports a stationary vertical cylinder of radius r and a disc A attached to the cylinder by a horizontal thread AB of length L0. You can see top view of the figure they have given. Here figure is there. An initial velocity V0 is imparted to the disc as shown in the figure. How long will it move along the plane until it strikes against the cylinder? The friction is azimuthally opposite. Now you see here, this irodov question and this question like Pathfinder question, 21st Pathfinder question, and this question, the major difference between the both the questions is coefficient of friction between the disc is there here, disc and floor here friction is there. Okay. In this question, in irodov question, friction is azimuthally absent, remaining same thing. Here also they are asking time taken. Here also they are asking time taken only. So this is a general question. 11th question is the general question. Here they are asking that how much length of the unwound segment in a given time t they are asking. Okay, these are the 4 questions I have taken from the Pathfinder, Krotov and irodov. Before going to see this my solution, I already written that solution. I will show that only. You can also try by yourself. Okay, you can after that you can check your solution with my solution. Okay, I am starting now. Here first question I have written already, you can see it. First question, this is Pathfinder 11th question. Here as per the question you can see, as a small disc placed on a frictionless horizontal floor is attached at one end, a light inextensible cord is there. Here it is connected to a body, like you can see that one end is connected to the D. Okay, this is a cylinder, this is cylinder. Here small disc is there. Okay, now disc is projected in a with a certain velocity perpendicular. See, you can see it is projected with a perpendicular to this cord. Okay, perpendicular to the cord along the floor. How will the tensile force, means the tension, this tension T is there in the string or cord, how it changes, and how speed, this speed V is there, that it changes during the motion they are asking. Okay, now you can see how it is there. After some time you can see my figure here. I have drawn the figure. In this figure, suppose say the thread is turning by certain distance. Let us consider this is the distance covered. How much distance it is covered I have taken. Suppose say during this time, if it is turning through an angle theta, the length of the cord, what it is on the cylinder is r into t theta, r into theta. Okay, suppose if I change whatever length is there, that length is changed by small amount. Let us consider the delta t theta, delta theta. Then I have written that what is the remaining length, which is unwound type is there, no, that value is how much. Total, as total length of the rod is, I have considered the L, r theta is actually wound. Remaining length you can see that L minus r into theta, as this is a theta, and you can write it as this angle also theta you will get. This distance, now you can say that delta s, later we can write it as V into delta t. Delta t also you can write, but it is not required in this case. The tension in the thread I have taken as T. Okay, you see, observe this carefully. Whatever the speed of the charged particle, speed of this disk is there, this disk is actually perpendicular to the thread or cord. Okay, as speed is perpendicular to the cord, we can see that whenever this speed, everywhere you can see, if it is going like this, there also speed is perpendicular to the tension in the cord. So whenever it is perpendicular to the cord, we can see that work done by this tension force. As we know that power delivered and work done, you can write it as T bar dot V bar is the power delivered by the tension. As T bar dot V bar value is equal to 0, power delivered is 0. If power delivered is 0, you can say that speed is constant and no work is done by the tension force. Okay, if no work is done by the tension force, you can say that the speed of the whatever the disk is there, that is remains constant throughout its motion. Okay, that's why I have written here. You can see here, as tension is always perpendicular to disk, work done by tension is 0, disk kinetic energy remains constant, speed remains constant. We can see where speed is remains constant. Here both remains constant is given. In fourth option, speed remains constant is there. And third option, it is speed is decreasing is given. That is wrong answer. Now, what will happen if it is the speed is remains constant? How tension in the string, the cord will be there. Okay. Now you can see that whenever it is moving, whatever radius is there now, you can see our length of the cord is r. That I have taken like a L minus r into theta. This L minus r into theta value is actually decreasing. Okay, it is wounding over the cylinder. Now you can see, as per our relation, tension only provides the, except the tension force, no one is providing the necessary centripetal force to this disc. Okay, I have written this T is equal to mv square divided by the r. As r value is decreasing, as it is moving, length of the cord is decreasing. Okay, r is decreasing, you can say that tension is increases. If tension increases, as per the question, they are asking that which is actually changing. Tensile force will increase and speed remains constant. This is the option D is the correct option. You can see it. Okay, here there is no friction. Okay, next one. You see question number 21, what they have given in same Pathfinder. Question number 21. In this question, the same thing they have given, what they are asking is how much time it takes. Actually, you can see this one is actually whatever the disk is there, by what time it is hitting this cylinder. Okay. But in this question, they have given coefficient of friction between the disk and floor is mu. Okay. I have considered this into two parts. You observe this carefully. My first thing is I have taken as the same thing. It is r into theta is a wounding part, and the remaining part we can say that d theta. Okay, now you can write the L minus R into theta is the remaining part. Okay, ds is equal to L minus R theta R into ds is equal to this is like a whatever the radius is there, that is L minus R into theta into d theta. This d theta, that is a ds. So we can say that this disk is moving a certain distance. That distance is equal to ds is equal to L minus R into theta into d theta. The same value you can write it as v into dt also you can write. Okay. Now in this case, while moving that, we can see that there is a this disk is actually having a tendency move upward direction. What friction will be there, whatever friction is there between the floor and disk is there, no, that is actually try to oppose this relative motion. So we can say that mu into n is there, whatever friction is there, mu into n, that n value is equal to, we can write it as m into g. So frictional force is mu into mg. I have written downward direction. Okay, downward means opposite to the v direction. Okay, and one more thing, no force is acting actually in this direction other than the friction. There is no force. So if I rate the whatever the acceleration of the body, F is equal to, we can write it as m into a. So we can write it as mu into mg is equal to this. So as motion of the body is opposite direction, I can write it as minus ma. M and m get cancelled. A value is equal to much minus mu into g. That's what actually I have written. I can see that acceleration of the body along actually along the motion of the body. Okay. Still we can say that tension is this direction. Okay. There are two conditions I am taking, as they are asking how long will the disc slide on the floor before it hits the cylinder. Okay, let us consider the first case. If thread is very long, see here I am taking like a thread is long. If thread is long, obviously because of this frictional force, before hitting the cylinder, because of the friction, body velocity, whatever disc velocity is there, that may be at rest, that maybe comes to rest. Okay, disc may stop. Okay, by what time it is stopping, I am writing. So I have used general basic relation, v is equal to e plus at, as a is uniform is there. I get the values t is equal to u divided by the mu g. This case is actually, you can observe that if the whatever thread is too much long is there, that time you can see that at t is equal to u by mu g, it will stop. Okay, before hitting this takes like a u by mu g if it's stopping. Next case, if thread is small, disc will hit the cylinder. Okay, if disc is hitting the cylinder, how much actually it is turning angle, you can see here. Actually length of the thread are called, I have taken as L. How much angle it is, maximum angle it can turn, that value can write as you know that angle is equal to length divided by the whatever the radius is there. Okay, the same thing I have taken here, radius value is equal to small r, we can take the small r. Okay, now you can see that this is the maximum angle. Okay, maximum angle this cord will turn over the cylinder is theta maximum is equal to L by R. I have taken the same thing, theta maximum is L by R. And as I have written earlier, whatever distance covered by the disc is there, that we can write as L minus R into theta is equal to V into dt. Same thing I have applied, ds is equal to integral V dt. My relation is actually at t is equal to 0, angle turn is 0. At any time t, actually the maximum angle is how much here, turning is theta max, that value is equal to L by R. Okay, we can see that whenever it is hitting the cylinder. I have integrated. General process of integration is there that I have applied. And before applying this v value, you know that v is equal to u plus at. From the above relation, we can see that u minus mu into g into t. I have written that a is retarding actually, disk is retarding, u minus mu g. I have substituted this u value here, v value. Integrated. I hope everyone knows that integration and all. We can see the steps. We can also follow this. I have found the value. After substituting that, I got the some t value. Okay. By solving this quadratic equation, I got the two relations. One is t1 whenever the positive value is written, like a plus or minus is there, no, plus 1 I have given t1 time, other one is I have given like a t2. Okay, you can see that disk when the disk is stopping actually before hitting the cylinder at t is equal to u divided by the mu g time, it is actually stopping. Okay, if it is stopping at t is equal to t is equal to u divided by the mu g, you see, observe this carefully. This is u and this is a mu. U is the velocity of the disk, mu is the coefficient of friction. I can see that it should not actually having more than this time. Okay, you can see in the first case, or whatever discriminity is there, I am writing like a middle term. This term is there, no, that term u square r should be greater than or equal to mu g L square. In this case, we can say that t1 is getting like a more than the t, so it is stopping before hitting the cylinder. Next, in the next case, we can see that if u is greater than root of L into root over mu g by r, will get actually in this relation. In the second case, t2 value is less than the t is nothing but this u divided by the mu g, so it will hit the cylinder. Okay, based on this, I have taken two things. If u is less than or equal to L divided by the L into root over mu g by r, in this case it will hit. If u is greater than or equal to L into root over mu g by r, so we can say that it will hit. Okay, these are the two cases. We can see this t2 time is hitting. Other one is first case, whatever I have written here. No, this first case is a possibility is there. Okay, before stopping, it will hit. These are the two conditions we can see it. As per the Pathfinder solution also, they are writing like a u less than or equal to what is the value. If u is greater than or equal to L by root over mu g by r, what is the value they are asking. So I have calculated the time taken. You can also try this one. If you want, we can see this solution again. Okay. Next question. This is from Krotov question. In this Krotov question, what they are asking is same question like a ball. Instead of this, they have taken ball. A ball is tied by a weightless inextensible thread to a fixed cylinder of radius r. As the initial movement, the thread is wound so that ball touches the cylinder. Then the ball acquires the velocity v in the radial direction and the thread starts unwinding. Okay, thread is starting unwinding. You can see that it is unwinding. Determine the length L of the unwinding segment of the thread by instant of time t, neglecting the force of gravity. Okay, here what they are asking, you need to calculate the unwinding length. We have to calculate. So initially it is having velocity v, now it is unwinding from here to slowly it is coming here like this, finally it is coming to here. Okay, that length we have to calculate in time t. Okay, in terms of t and length L r, length L you have to calculate in terms of the t, r and v. Okay, these terms are given. What I am doing is, just the same diagram I am drawing now. You can see I have taken this whatever the unwinding thread is there, I have divided into small parts. Each one I have taken delta L. Let us consider this is also delta L. According to me, I can write as whatever the winding part is there, delta L. The delta L can be written as r into delta phi, or delta phi can be written as delta L divided by the r. You can see here. If I write this term also, how much angle will be there? Delta phi n. I have divided this into small parts like a delta L, delta L, delta L, like this. I have divided into n equal parts. Okay. How much distance it is covering actually ball in delta tn time. Actually, I have taken like a each part like a delta t, delta t, delta t, like that. Delta tn parts, delta tn times I am writing v into delta tn. nothing but actually to unwind this length. Okay, in delta L1 is there, no, that in delta T1, delta L2 means for two parts, actually we can say that two deltas are delta T2 time, like that n equal parts I am taking like a delta Tn time. Okay, delta Tn is nothing but sum of the all the times, actually delta L1 time, delta L2 time, delta L3 time, like that. Okay, this delta n can be written as actually total length is L. Okay, this can be written as n into delta L. From there I have written delta L value is L divided by the n. Okay, here also same process I am telling, as tension is perpendicular to the velocity and no work is done, kinetic energy of the ball remains constant, as well as speed also remains constant. Okay, this part you have to keep in your mind. Okay, next one, whatever the angle is there, delta phi or delta phi n is there, I am writing in terms of this. This distance is equal to v into delta theta n divided by the total length is equal to much n into delta L. You can see here total length is n into delta L. I have written. So I am taking this as in terms of delta n I want. So you bring this one is this side. We can write it as n into delta L into delta L whole divided by the r into v is equal to delta theta n. So I have written the same relation here, n into delta L square divided by the v into r is equal to delta theta m. Okay, now my total time taken I am writing delta T1, delta T2, delta Tn, so on. Okay, for all nth parts I have written. What is the delta n values? We can see from this relation, n into delta L whole square divided by the Vr is there, no, that I am writing now. First part, n is equal to 1. Second length means two lengths are there, 2 into delta L square, nth part, n into delta L square divided by the Vr, that is a delta theta m. Okay, if I use this all sum, if I do that, you know that in mathematics you will get n into n plus 1 by 2 into sum of these all terms, n into n plus 1 divided by the 2 into delta L square by Vr I have written, and t is equal to I have taken delta theta n. Okay, delta Tn, sorry. Why? Because they have given t value. I substitute there, as n is very small, n plus 1 can be written as actually not n value, actually n plus 1. If you compare with the n lengths, one length is very less, so we can say that n plus 1 is considered as n, and delta n, n into delta L value, you know that L. I substituted there, n into n plus 1 can be written as n into n, that is n square I have written, delta L square I have written, and n into delta L value is equal to L square. I used that n into delta L square is equal to L square, and 2 into Vr is as it is there. So finally I got the value is as per the given answers. L is equal to, we will get the root over 2t into Vr. So observe this carefully, how much length is unwind, okay, in time t. The ball is actually given initial radial velocity, radial speed is given that v. Okay, observe this carefully, this is the answer. Next, fourth question, which is from the irodov. In this question, it is similar to the Pathfinder question only. Pathfinder, whatever I have done earlier, same 21st question. The major difference between this question and Pathfinder question is there is no here there is no friction. Same question they are asking, how long will it move along the plane until it strikes against the cylinder. Same thing, same process we can follow. Velocity is perpendicular to tension, so tension is perpendicular to that initial velocity of disk A, so that we can say no work is done by the tension, speed is remains constant. You can see that how much time it takes, distance traveled by speed is there, no, that we can write it as speed is constant, you can write the time is equal to distance by speed. Time is equal to distance by speed, you can write as per the basic relations. Same process, delta small theta I have written, r into theta is 1, and remaining part is equal to much L minus r into theta, and proceeded the same thing. Whatever ds is there, that can be written as v into dt, you can write. Okay, ds is nothing but L naught minus r into theta into d theta. Process I have followed that. Anyway, they have not asked that what is actually t value only they are asking. I can do like integral ds is equal to integral v dt also, but I have written here ds is equal to L minus r into L naught minus r theta into d theta. integrated from 0 to S, 0 to theta maximum. Earlier I have given same value, theta maximum total length L0 divided by the radius of this cylinder. I got the relation finally, S is equal to this much, T is equal to distance by V is there. I can use this relation, L0 square divided by the 2R V0. You see the 4 questions properly. I hope you have enjoyed this, and I am telling again, before seeing my this handwritten solution, already I am showing this. You can try first. Before that, just we can see